Hello friend. Now in this lecture we are going to discuss the important topic of real analysis, that is sequence of real number. Now we know the definition of set. Now see what is the definition of set. Set, it is the collection of well-defined object. See what is the definition of set? Set, it is the collection of well-defined object. Now suppose if we consider set A is equal to, it contains suppose 4 element 1, 2, 3, 4, and consider suppose B is equal to, which contains 4, 3, 1 and 2. Then according to set theory, we can say that this set A, this is same as set B. Because in set theory, the position of element does not matter. We can write the element anywhere. So in set theory, the position of the element does not matter. So we can say that this set A, this is same as set B. Now suppose if we consider sequence A is equal to, which contains suppose the finite element 1, 2, 3, 4. Now later on I will give the proper definition about the sequence. So consider the sequence A is equal to 1, 2, 3, 4 and consider the next sequence, suppose B is equal to, sequence contains 4 element 4, 3, 1, 2. Then according to sequence theory, we can say that this sequence A, this is not equal to sequence B. Because in sequence, the position of element is matter. In the first sequence, this is the first position of the element. This is the second position of the element. This is third position and this is fourth position. In second sequence, 4 occurs in the first position. This element 3 occurs in the second position. Element 1 occurs in the third position and this element 2 occurs in the fourth position. So that's why this sequence set is different from sequence B. So remember this concept. In set, the position of the element does not matter, while in the sequence, the position of the element it's matter. Now see, we define this sequence with the help of function. Now suppose if we consider F as a mapping from set A to set B, then this A, this is called the domain of the set, and this B, this is called the codomain. See, if we consider F as a mapping from set A to set B, then what is this A? A, that is called the domain, and this B, it is called the codomain. Now if we consider suppose domain is equal to suppose -1, 0, 1, 2, and consider this codomain B is equal to, consider suppose this is 0, 1, 2, 3, 4, 5, 6. And consider suppose the function f(x) equal to suppose, let us take suppose x square. Now we have to take the values of x from this domain set only. That means we have to take x equal to -1, 0, 1, 2 and so on. So let us take the values of x from this domain. Now suppose if we put suppose x equal to -1, then what is the value of f of -1? -1 square, it is 1. Put x equal to next element which is 0, then what is f0? f0 will be 0. Put x equal to next element which is 1, just take the element from A. What is f1? f1 will be 1. Put x equal to 2, so what is f2? f2 will be 4. Now see, these elements are called the range set. These answers or this element, it is called the range set. So what is the range of this? So range set, this is equal to, it contains these elements. So just this is a set. So we have to write the element at one times only. So range set, what is the range set? It contains 0, 1, 4. Now see, this range set, it is different from this codomain. Range, this is the subset of codomain. See, there is a difference between the range set and codomain. Range, it is the subset of codomain. We have found this range set equal to 0, 1, 4. And what is our codomain? Codomain contains these 7 elements, 0 to 6. So always this range set, it is the subset of this codomain. Subset means it may be less or it may be equal. So remember this concept. Always this range set, it is the subset of codomain. Now consider, suppose this following sequence. This is the sequence of natural number 1, 2, 3, 4, 5, ... n and so on. Now suppose if we represent the first element, suppose by A1, represent this second element by A2, represent third element by A3, represent fourth element by A4 and so on. What is this A? A means it is the element, and this 1, 2, 3, 4, it represents the position of that particular element. Now see what is the function or what is the sequence. Sequence, it is a function from natural number to S. Suppose. If you consider, suppose S equal to, suppose consider this sequence A1, A2, A3, ... an. Just consider this finite sequence, suppose. So what is the sequence? Sequence, it is a function whose domain is a natural number, and consider, suppose, the codomain as a set S, where what is this S? S which contains this n element A1 to An. Now suppose this, if this is subset of natural number, then this sequence, it is called the sequence of natural number. If suppose this S, if this is subset of integers, then this sequence, it is called the sequence of integers. If suppose this S, if this is subset of rational number, then this is called the sequence of rational number. If S, it is a subset of real number, then the sequence, it is called the sequence of real number. If S, it is a subset of, suppose, complex number, then this sequence, it is called the sequence of complex number. But in real analysis, we are talking about just the sequence of real number. Or we can say that it is the infinite sequence of real number. Or instead of this word infinite sequence of real number, we just use the word it is the sequence of real number, or we can just use the word it is the sequence. So see what is the proper definition of the sequence. Sequence, it is a function whose domain, it is a natural number, and codomain, it is a real number, defined by this An is equal to An for all n belongs to natural number. We have to take the element n from this natural number. Natural number means contain the element 1, 2, 3, 4 up to infinite number. So this is what the definition of the sequence. What is sequence? Sequence, it is a special type of function. Sequence, it is a function whose domain, it is a natural number, and codomain, it is a set of real number, that is called the sequence of a real number. Now we shall write down some example of sequences, and obviously that is the infinite sequence. Now first of all note this. This is the notation for writing the sequence. Usually sequence it is denoted by the notation. This is the notation for sequence. Sequence AN, or we can write this notation sequence XN. Or we can use this bracket sequence AN or sequence XN. And obviously what is the variation of n? N varies from 1 to infinity. Now suppose if we consider the sequence AN is equal to suppose 1 upon n. So this is the well-known sequence, that is 1 upon n. So what are the element of this sequence? We have to take the element of n from natural number. Now suppose if we put n equal to 1, then what is the first element? It is 1. Put n equal to 2, then what is the next element? It will be 1 half. Put n equal to 3, then the next element will be 1 by 3. Put n equal to 4, this is the next element, which is 1 by 4. So this is our sequence. Sequence AN, it contains the element 1, 1 half, 1 by 3, 1 by 4, 1 by 5, dot 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 1 upon n. This is called the general term of the sequence, and so on. So see what is the range of this sequence. Just now we have seen the definition of range. What is range? Range of sequence, it is just a set which contains the different element from the sequence. So what is the range of this sequence? Range of this sequence. What is range? Range, this is nothing but the set which contains the different element of the sequence. So it contains the same element 1, 1 half, 1 upon 3, 1 upon 4, 1 upon 5, and so on. So see, if you consider this sequence n equal to 1, 1 half, 1 by 3, 1 by 4, and so on. So what is the range of this sequence? It contains the same number of elements. So remember, this range, either it is the subset or it may be equal. Now consider the second example of this sequence. AN is equal to minus 1 raised to n. Now put n equal to 1, so what is this sequence? This is, if you put n equal to 1, suppose we have to take the element from the natural number, that is the domain set. Put n equal to 1, so this will be minus 1. Put n equal to 2, so minus 1 square, it is 1. Put n equal to 3, minus 1 cube, it is minus 1. Put n equal to 4, minus 1 raised to 4 means it is 1. So it contains the same element minus 1, 1, minus 1, 1, minus 1, 1, and so on. So this is the infinite sequence of this real number. So what is the range of this sequence? Range of this sequence, it contains just 2 elements. Range, this is just a set. And in set, we have to write the element at one time only. So it contains just 2 elements. Range of this sequence, this is nothing but minus 1 to 1. So range, either it is the less or it may be equal to the sequence. Now consider the third example of this infinite sequence. Suppose it is n square. So what are the elements? Put n equal to 1, so this is 1 square. Put n equal to 2, so this is 2 square. 3 square, 4 square, so this is our sequence. So what is the range of this sequence? Range of this sequence, it contains all the term. See, what is the definition of range? Range, it contains the different term of a sequence. So this range of this sequence contains all the element 1 square, 2 square, 3 square, 4 square, and so on. So see, in this lecture we are seeing the definition of sequence and we are seeing what is the range of the sequence. So what is the definition of the sequence? Sequence, it is a function whose domain it is a natural number and codomain it is a set of a real number. That's why it is called the sequence of or infinite sequence of real number. So thank you for watching.